I was saying that the bonding situation is metallic if the two identical atoms are of metals. The bonding situation is metallic. The bonding situation is metallic if the two atoms, if the two identical atoms are of metals. The bonding situation is metallic if the two identical atoms are of metals. So that means that if we are having a bonding between a metal, two atoms of a metal, we will end up with what we call the metallic bonding. And then that one would be referred to as the metallic radius. Therefore, it would, therefore the radius in this case, therefore the radius in this case is referred to metallic radius, is referred to as metallic radius, because we are getting it from bonding two atoms, two identical atoms of a metal. But when the bonding situation is covalent, if the two identical atoms are of non-metals, that is covalently bonded together. The bonding situation is covalent if the two atoms are bonded covalently. If the two atoms are what? Are bonded covalently. And that radius would be referred to as the covalent radius. And would be covalent radius. In most cases, the one we refer to as the atomic radius. So when someone, in most cases, they say atomic radius, they are meaning the radius that is as a result of bonding atoms covalently. And we know that covalent, that is the kind of bonding that happens between two non-metals. We are having two non-metals and then they bond. That is where we get the covalent bonding. So we are going to have the illustration of the atomic radius. Illustration of atomic radius. The illustration. And from the illustration, that means it is a diagram. We are having two atoms coming closer or coming closer. So we have, let me also get this off. We have the first atom and then the second atom. The first atom and then the second atom. And we are saying that an atom has a center called a nucleus. The atom has a center called nucleus. And we are saying that atomic radius is the distance of closest approach of the nucleus of two identical atoms. So we have this one using dotted lines. This part here would be the atomic radius. The atomic what? Radius, because it is the one that comes to the distance of closest approach from the nucleus to the atom. And then we have the distance between the two identical atoms. That is from here up to here. Distance between two identical atoms. That is how our simple illustration would be. That is how the simple illustration of atomic radius would be. So we are going to look at factors that affect atomic radius. Factors that affect atomic radius as it moves down the group and as it moves across the group. We are going to see what happens to that atomic radius. So what do you think? What would make the atomic radius, or what would make the distance between the nucleus of two atoms become small, become big, become medium? What would bring about that? We have one what we call the nuclear charge. And the nuclear charge is defined as the attraction of positively charged nucleus for the outermost electrons. Factors affecting the atomic radius. Factors that affect the atomic radius. And we are saying that number one is what we call the nuclear charge. The nuclear charge. And from its name, we know that nuclear is coming from the word nucleus, charge. So we are looking at the charge of the nucleus. If this is our nucleus, how would its charge affect the atomic radius? And from the previous lessons, I said that the nucleus contains contains protons and neutrons. And we know that neutrons don't carry any charge, whereas protons are positively charged. So the protons would give the nucleus a positive charge, meaning that our nucleus is positively charged. That's why we are defining it as the attraction of positively charged nucleus for the outermost electrons. The attraction of positively charged nucleus is the attraction of positively charged nucleus, for the outermost electrons. For outermost electrons. the attraction of the positively charged nucleus, because we've said that the nucleus contains protons, and we know that protons, these are positively charged particles. So that positively charged nucleus tends to attract electrons in the outermost shells, or in the outer shells, because in the previous lessons we looked at energy levels, or what we call shells. So those electrons in those shells are attracted towards the nucleus, because electrons in nature are negatively charged, while protons are positively charged. So there is always a bit of attraction between the positive and then the negative. So we are having our atom. We are having our atom having the nucleus, and then having the different energy levels. The different energy levels, and these energy levels contain electrons. So all these electrons are being pulled towards the center of the nucleus, because the nucleus has the positive charge. All the electrons in the various shells, in the various energy levels, they will be pulled towards the center of the nucleus. Another example we can give is sodium has atomic number. Sodium atom has 11 protons in its nucleus. That gives it a nuclear charge of 11. E.g., sodium atom has 11 protons in the nucleus. Therefore, the nuclear charge of sodium atom is plus 11. Is plus what? 11. Because the nucleus of the sodium atom is only having 11 protons, to balance with the 11 electrons that sodium has. So since the 11 electrons are already negative, we need a number that is a positive. That is why the nuclear charge is being positive, because we said the nucleus is positive, such that the overall sodium atom will be neutral. If an atom has high, if the atom has high nuclear charge, then its atomic radius will increase. If it's not right, if the nuclear, if an atom has high nuclear charge, if an atom has high nuclear charge, if it has high nuclear charge, that means the attraction of the nucleus of an atom, the attraction the nucleus of an atom has for its electrons is greater. If an atom has high nuclear charge, the attraction the nucleus will have the attraction the nucleus will have for electrons in the shells is high. In short, the higher the nuclear charge, the more the attraction for the outer electrons, then the smaller the atomic radius. Leading to decrease in the atomic radius. If an atom has high nuclear charge, the attraction the nucleus will have for the electrons in the shell is high, leading to decrease in the atomic radius. Leading to the decrease in the atomic radius. Then if the charge is low, that means it would be the opposite of this if the charge is low. So let's get that one from this one. If let me start from around here such that I don't have to rub. If an atom has low nuclear charge, the attraction the nucleus will have, the attraction